Hello. Hello, everyone. First of all, thank you for coming to this talk. And I hope that you have been having a nice time at AWS reInvent. My name is Mohammad Wasiq, and I'm one of the lead security engineers in Amazon GuardDuty. My core job in GuardDuty is to research, develop, and continuously improve its threat detection capabilities. And during the last 3 years, I have been focusing on GuardDuty runtime monitoring. In this talk, you'll learn how GuardDuty gathers information about real-world threats, how it uses this information to prioritize and implement threat detections, and how you could use realistic attack scenarios to test GuardDuty runtime monitoring. For those of you who don't know what GuardDuty is, it is a threat detection service that monitors various log sources in your AWS account, such as CloudTrail logs and VPC flow logs, and applies machine learning and detection rules to detect threats in real time. And what is GuardDuty runtime monitoring? It's an optional runtime monitoring solution offered by GuardDuty. It involves deploying an eBPF agent to your AWS compute workloads, such as EC2 instances. The eBPF agent gathers various operating system level events and sends those back to GuardDuty backend for monitoring and threat detection. An important question to ask is, why do you need to test the runtime monitoring solution? An obvious reason is you would like to evaluate the runtime monitoring service to make sure that it meets your requirements. Another important reason is that you would like to test your incident response capabilities, because it is really important to have a robust incident response procedure to respond to runtime monitoring findings. We have noticed that many customers use simplistic tests when testing runtime monitoring. And these simplistic tests often map to a single MITRE technique. For example, a customer would create a cron job to test detections for persistence activity. There are two primary issues with these simplistic tests. First of all, they are not realistic. Secondly, they do not provide you any information about the noise reduction or the noise management capabilities of the runtime monitoring solution. So you can see that all of these actions are very common actions in benign activity as well. For example, creating a cron job is a very common benign activity. So when you use these simplistic tests, you don't get any insights into how good is the runtime monitoring solution in filtering out benign activity from the actual threat activity. So for more effective testing, you need more realistic attack scenarios, and this is what you are going to learn in this talk today. First of all, let's see how GuardDuty gathers information about real-world attacks. The first and one of the most important sources of information are the actual customer incidents. We have a team called AWS CERT, or Customer Incident Response Team, that helps customers in responding to their security incidents. And from these customer engagements, we gather valuable information about tactics and techniques used in actual attacks against AWS customers. We also learn about the most common or the top techniques used against AWS customers. Based on data from AWS CERT, the top 2 initial access techniques used in attacks against AWS customers are compromised credentials and public-facing application compromise. Compromised credential means that an attacker is able to get hold of your AWS credential or IAM credential and uses it to gain access to your AWS account. From there, they could exfiltrate data, send out spam emails, or create compute workloads for resource hijacking. Public-facing application compromise means that you have a vulnerable public-facing application The attacker is able to compromise the vulnerability and gain access to the underlying compute resource, such as the EC2 instance. And from there, they can perform various activities, such as crypto mining or DDoS against other targets on the internet. Data from AWS Search shows that a vast majority of attacks against AWS customers deploy these two initial access techniques. And this is the reason why GuardDuty prioritizes developing detections for these techniques, not just in GuardDuty runtime monitoring, but other GuardDuty features such as CloudTrail monitoring. Furthermore, the real-world attack scenarios that you'll be learning about in this talk are also based on these two initial access techniques. Another source of information on real-world attacks is the threat intelligence that GuardDuty consumes. GuardDuty uses various in-house and third-party sources of threat intelligence, and this is what we learn from these threat intelligence sources. First of all, we learn about indicators of compromise. These are the IP addresses, domain names, and file hashes used in real attacks. We also learn about the tactics and techniques used in real attacks and various activity patterns used in real attacks. Last but not least, we also learn about the context surrounding real-world attacks or real-world threats. The context is really important because it informs GuardDuty about the types of applications and environments as specific threat targets and the sequences of tactics and techniques they deploy. Let's try to visualize and understand all this using a simplistic real-world attack scenario. Web application compromise is one of the most common attack vectors routinely captured by our honeypots. This is how a typical web application compromise works. The attacker compromises a vulnerability in the web application to deploy a web shell. Once they have deployed the web shell, they can execute any command on the underlying operating system. Typically, what we have seen as the first step, what they do is that they download a script, a shell script, which is a script malware, and execute it. Then the script malware is used to download a second stage malware, which could be a crypto miner or a DDoS malware or anything. Then, of course, they make the second stage malware executable using the chmod command. And then finally, they execute the second stage malware. And usually, the attackers also persist the execution of the second stage malware by creating a scheduled task or a cron job. You can see that all of these actions or activities map to specific MITRE tactics and techniques. You can also see that we learn about specific patterns used in these techniques. For example, in this case, the attacker uses the curl command to download a script malware from an IP address-based URL and pipes it to a shell process. Another interesting pattern is the creation of the cron job here. In this case, the attacker writes the instructions for the cron job to a temporary file and loads that temporary file using the cron tab command. And we also learn about the context surrounding all these actions or steps. So for example, in this case, all these actions originate from a web application or a network-facing application, and they follow a very specific sequence. So this example demonstrates how GuardDuty learns about tactics and techniques and activity patterns used in real attacks or real threats, and how it uses it to prioritize and develop threat detections. Now let's see how you could test GuardDuty runtime monitoring using realistic attack scenarios. We have added multiple realistic scenarios to Amazon GuardDuty Tester. Let's see what is Amazon GuardDuty Tester. Amazon GuardDuty Tester is a public GitHub repository which allows you to test various GuardDuty findings. You can search it on Google, When you load the main page of the GitHub repository, you find easy-to-use instructions to set up a secure test environment, lockdown test environment in your AWS account. When you follow these instructions and execute these instructions, they set up a lockdown VPC in your AWS account with various resources such as EC2 instances, an ECS cluster, and an EKS cluster. Once you have set up the test environment, the next important step is to make sure that GuardDuty runtime monitoring is enabled. Open up the GuardDuty console. On the left-hand side, click on Runtime Monitoring link. There it is. This will take you to the main runtime monitoring enablement page. Make sure that runtime monitoring is enabled. In this case, it's enabled, but the agent management for AWS Fargate is not enabled. Let's go ahead and enable it. Also, the agent management for Amazon EC2 is not enabled. Let's go ahead and enable it. So now the test environment is set. Let's go ahead and execute the test. So you are going to execute the test in 2 steps. In the first step, you are going to deploy a vulnerable PHP application on the EKS cluster. And in the second step, you are going to execute an attack against that PHP application. Let's go ahead and do that. When you create the test environment using Amazon GuardDuty Tester, it creates several EC2 instances in your AWS account. One of those instances is driver GuardDuty Tester. You're going to be connecting to this instance using SSM start session to start a terminal session. And from there, you will be executing the attack scenario. Let's open up the Amazon GuardDuty Tester repository again. It provides the command, the SSM start session command to connect to the driver instance. Copy that command. Now open up a terminal window on your client-side host. Make sure that it is set up with AWS CLI and also has permissions to perform SSM start session. First, set up the region where you have installed or created the test environment using Amazon GuardDuty Tester. Now paste the command and execute it. Now you are logged into the driver instance. So inside the driver instance, you will find various files and directories. One of those directories is runtime scenarios. Let's look into this directory. You will find various realistic scenarios here. One of those is PHP Web Shell, and this is you are going to execute today. Let's go ahead and look inside PHP Web Shell. So in this directory, you will find 2 different scripts. One is deploy PHP, and the other is attack. Deploy PHP deploys the PHP web application on the EKS cluster. Let's go ahead and deploy the PHP web application. When you execute deploy PHP, it creates an ECR repository and loads a PHP Apache container image to it, and then uses that image to create an EKS pod on the EKS cluster. So now the pod is being created. Let's wait a little. So the pod is now created, and this is the name of the pod, and this is the IP address where the web application is accessible. After creating the pod, the script also performs various setup steps on the pod. One of the more interesting setup steps is to set up a command and control server to simulate command and control communication for the scenario. Now the PHP web application is deployed. Let's go ahead and execute the attack. When you first start the attack script, it asks permissions to modify or to create the necessary GuardDuty permission settings in your account. Allow it to do that. As the first step of the attack, the script gets the IP address of the PHP web application. Then it accesses the index.php, exploits the vulnerability to deploy a web shell. Once it has deployed the web shell, it executes various commands through it. For example, it executes various discovery commands. It downloads malware and executes it. So here you go. This completes the execution of the attack scenario. Now let's see what finding GuardDuty generated. Let's open up the GuardDuty console and click on the findings link on the top menu. This will take you to all the findings generated. The scenario should have generated multiple findings. For example, when multiple commands were executed through the web shell, GuardDuty generated a high severity suspicious command finding. To make sure or to verify that it originated from the PHP web application, let's look at the process lineage of this finding. And here you find that the parent is Apache 2, which means that it actually originated from the PHP application because we are using Apache to run PHP. The attack scenario also executed nmap for network reconnaissance. And because of that, GuardDuty generated a suspicious tool finding. Let's scroll down, and you can see that the name of the process is nmap. So here it is. The attack scenario also downloaded and executed a crypto miner. So GuardDuty generated a crypto miner executed finding. Let's look into this finding. And to verify that it also originates from the PHP web application, let's look at the process lineage of this finding as well. And here you can see that the grandparent is Apache 2, which means that it actually originated from the PHP web application. Last but not least, GuardDuty also generated an attack sequence finding. So this is an aggregate or the composite finding, which provides the comprehensive view of all the tactics and techniques and signals detected during the attack scenario. So here you go. So these are the key takeaways from this talk. So in this talk, you learned how GuardDuty gathers information about real-world attacks and uses it to prioritize detections and implement threat detections, and how you could use realistic attack scenarios to test GuardDuty runtime monitoring. And we have added multiple realistic scenarios to Amazon GuardDuty Tester GitHub repository, which you can access from this QR code. And we'll continue to add more scenarios to it. And thank you again for attending this talk.